I got a comment from the Peanut Gallery today at ZEPH0 Okay, so I will read this comment. Nice representation of the Earth in its great year, but unfortunately the Earth is not a styrofoam ball stuck to a skewer atop a motorized spinning plate, and so it does not behave like one. Can you demonstrate how an object's orientation must remain constant relative to an object it orbits around without physically connecting the two objects? Because I can easily demonstrate a case where that doesn't happen. In the setup you used, instead of sticking the sun and earth onto dowel rods fixed to a piece of wood, float them in cups of water instead. Mark a point on the ball to represent an axis and place them on opposite sides of the spinning plate just as you had them in your model. Then turn the plate on again. If you start with one tilted toward the other, then by the time it reaches the opposite side of its orbit, it will be tilted away. All right, I love it. I love it. Now, I like this experiment, and I am in such a hurry to see this demonstrated that I will pay Zephyr Shade whatever it costs for him to buy the materials and make this demonstration and post it on YouTube. Now, I would do it myself if it wasn't so patently stupid. And let's take a look at this guy's premises, okay? Now, if you float balls in a cup of water, wait a minute. First of all, let's go back to basics, okay? You know, it's sad that I have to do this, but clearly, and this isn't just for him, because I know there's a million more idiots out there too, but let's just take this representation, right? This is Earth, okay? This is Earth tilted on its axis. Now, do I need to point out that the Earth is rotating on its axis? I mean, must I do that? Okay. Earth is spinning, okay? That's motion one. Now, my plates, which rotate, let's have a look. Get it? Okay. You get that? That's an orbit. That's the orbit. That's motion two, orbit. Motions. I can make an orrery that will have the sun, we'll have the sun in the center and the earth revolving around it. I can make an orrery that will have earth do this, like they show in the stupid cartoons. Go from here to here, okay? I can make an orrery that will do that, but it will require 3 motions, okay? This, according to astronomy, only has 2 motions, all right? I will give anybody $1,000 who can make anything start over here and end up over there orientated different about the center with 2 motions. Now, one motion is the Earth spinning on its axis, and the other motion is Earth revolving? I can make an orrery that'll do that. It's not hard to do, but it'll take 3 different motions. You'll have to make this revolve, and the Earth will have to be on a cam. You'll have to be a counter-rotational cam that'll basically just keep this thing steady. But you can't do it with 2 motions. You can't do it. It's non-geometrical. And that brings me to my next point. Let's see what he said. Can you demonstrate how an object's orientation must remain constant relative to an object it orbits around without physically connecting the 2 objects? No, and neither can you. The point is that that's the best I can do in a 3D model, you know? Focus, you. That's the best I can do in a 3D model, okay? I mean, what do you prefer? This, you know, a 2D model that, yeah, you do prefer it, because that way you can get away with doing stuff that isn't physical, but I don't do that. I don't do that here. So yeah, this is my physical model. But here's the thing. This sphere, this angle, this rotation, it's all geometry. It works. That's the point. And if you think NASA isn't using geometry, then you'd be sadly mistaken. I will post a very informative paper NASA put out some years ago. Now, it's for kids. You might not understand it, but I will post it, and you will see that every single thing NASA does is based on geometry. If you don't know anything about trigonometry, then you don't know anything about astrophysics, because it's all based on trigonometry and geometry. Back to this guy's contention. They can't handle the demonstration because they're under the spell of school that tells them that that happens, and that's what causes the seasons. But look how dumb that whole concept is anyway. Now look, you'll see this goes around, right, and it never changes. But that still doesn't have the ability, I mean, that still wouldn't have the ability to point at the same star, because if it did go around like that, let's suppose that it goes around, okay? Goes around in its orbit. Well, it's moved this distance. That's 1 AU. I mean, come on. That's 1 AU. So it's gone that distance. So that's not pointing at the same place anymore. I mean, they just show you this. It just goes from here to here, right? Well, let's just suppose it did go from there to there, and it's pointing at something up here. Up here. Well, if you went that distance, you'd have to continually change the axial tilt to still point at the thing. I mean, go outside on a given night and try to align a tracker for a telescope with Polaris. Have you done that before? It's very hard to do, because all you've got to do is bump that thing and it's no longer in alignment. And so we're supposed to go a whole 150 million miles that direction, but we're still pointing at Polaris. You can't even keep Polaris in the side of a telescope down here on Earth with a, you know, with a expensive piece of equipment. I'm really looking forward to this demonstration from Zephyrshade. I'm really looking forward to that experiment. Like I said, Zephyrshade, I'll buy you this. I'll buy, I don't know what you need. You just tell me what you need. I'll pay for it. I will pay for it. I'll be more than happy to pay for it. Now, you're gonna have to get your own camera. I'm not gonna buy that.